Let's use our Jiralib library in our main mod. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous episodes, we finished our Jira library as much as possible. I think it's time to make sure that we can use it in our main mod. We had published it on Maven, and let me close all of these. And good, that took few episodes by itself. Going back to our main mod, we go into Gradle.properties and make sure that we are using the proper version on Jiralib, and that is 2.0.0 Minecraft 5. And finally, in our build.gradle, we want to uncomment the dependency. And finally, we can right click on Ultra IO and let's close the Jiralib and reload Gradle project. I will come back when it's finished. It should download our Jiralib. As you see, it downloaded all 4 files for us and it's finishing the indexing. Good. Now let's go back and see where we are using these and we can utilize them. The first one is our GUBase. GUBase is using abstract activatable block. Now it's not finding it. Let's put the K there and you see that it found it now. And here the interface is iTick now, not iTickable or iTickBE. The last one is here, base items, and this is mod items, not base items. Okay, finally the GUBase is finished. You may notice that it's activatable block and I'm writing the unused because I don't want to activate it by clicking on the block. But I'm overwriting the unused with item so that when I'm clicking the block with an item in hand, that is when I'm checking if it's the rod copper, and then we are handling the usage of that and activating the block. So anytime you are using abstract activatable block, you have to fix this guy. Another thing that I remember that was using it, the machines are not using it, but in DataGen, I think the model provider, abstract activatable block that activate. And these are related to machine blocks. Of course, we don't have the machine blocks right now, but as you see, the errors related to GU is gone. So let's check these. The GU errors are gone. Here we have a problem, and oh yeah, these are the namings. I forgot to fix them. Okay, the GUs are fixed. Again, here should be fixed. Block entity type. Oh, okay. So the block entity types, those were the blocks. The block entity types, where are you? BE. These are that and that. So what am I missing here is implementing the method for tick client and untick client. And of course, these will have no functionality. So I will keep them as empty. And I have to do that for every one of these. So add a E here and remove that and import and just implement the methods. And as we finish that, you see that these errors will be gone. This should be fixed. There we go. So there is no errors there anymore. Mod item groups. Now the GU here should be fixed and we only have the machines as problem. The mod materials are okay now. The block tag provider, same errors, just the machines. Language provider are, what is the problem there? No problem there, just the machines. And again, these should be machines. Reference identifier. What is wrong here? Don't you have the identifier mod reference? Oh, okay. The reference that will fix that one. So there we go. Now what is the thing? Create mod reference. Oh, it was fixed. So again, only machines. This guy is machines. This guy is machines. And here we fix the problem with the payload. So GUBase is okay. And all remaining is our block entity fixing, just importing and then implementing the methods as empty bodied methods, And I will do it between the episodes. And that's the beauty of having a library. Okay, now after editing the block entities, I noticed something. It's okay to have the tick and tick client overloads, but our API was forcing me to insert the on-tick client end to every single one of these block entities. Now I deleted the Maven repository and I deleted the local cache on my hard drive. That is why you see these errors. The point is that the end methods shouldn't be handled by the user himself. Normally, it's something that should be covered on the backend on the base abstract classes, and the user shouldn't have to get involved with it. And as you see, the updatable is the one responsible for this, and update method is already implemented, and that is why you don't see any of these methods forcing me to overwrite the update. So all I need to do is to put on tick client end here as an empty method for time being. Basically, I don't have anything to do on the client side. And if I republish the Maven repository and go back and delete all of these on ticks for the client on the client end, it should work, okay? And it shouldn't be a problem anymore. However, there is something else that I forgot to do when I was moving toward the end of the videos, and I thought to myself that, you know what, I really want these things to be there. So let me clean my few remaining block entities and I will come back and talk about them. Okay, first one is the fluid stack payload. Now, fluid stack payload has the ID and just the codec and packet codec. First of all, this is called create. It should be a map codec. Okay, so it should be a map codec, and then fluid variant.codec.field of for getter, then the long field of for getter, then apply instance and fluid stack colon new. This one should be map codec. Okay, so this is one thing that needed to be covered. Also, for the fluid stack, I want to have the same thing that I did have on another one, and that is the empty instance. So public static final, a fluid stack payload, I will call it empty, equals to new fluid stack payload with fluid variant dot blank with the amount of 0. That's the empty. Also, I want to add few methods as helper methods for this, and I'm just copying them from what TurtiWorty had. Public boolean is empty, so it will check if this dot amount equals to 0 or this dot fluid dot is blank. After that, we want a method to match the fluid with something else. So public boolean matches, and here we sent in a nullable fluid stack payload. We call it other, or I can call it the stack, what not. Let's use the stack. And here we say if this equals empty and other, or here we call it the stack, equals to empty, return true. So that's one case. The other case, we return if the stack equals to null. If that's the case, we return the is empty. Otherwise, we say this dot fluid dot equals, we are comparing it with this stack dot fluid, and this dot amount should be equal to stack dot amount. If those cases are met, then we are matching. Now for the amount, I will say greater or equal to, because that's okay. The other method is public that returns fluid stack payload, and we call with amount, and we give a new amount here. We return if amount is less than or equal to 0, the empty one. Otherwise, we want a new payload of this dot fluid, comma, the amount that we sent in. The next one is public boolean test for recipe. The fluid stack payload, we call it a stack. All we want to do is say return this dot fluid dot equals with the stack dot fluid as the method, and this dot amount is greater or equal to the stack dot amount as the method. And by the way, this should be the method call. Okay, finally, the last one is a public boolean test for recipe that sends in a single fluid storage. Now, we didn't talk about fluid storages yet, but in the next episodes, when we start to work on our fluid library, you will get informed and you will get familiar with the storages more and more. Right now, all we want to do is check if the fluid storage is actually null, then we return false. Otherwise, we return if this dot fluid that equals to the fluid storage that we sent in, and from the storage we want to get the variant, because the variant is the fluid type, and this dot amount is actually less than or equal the fluid storage dot amount. Now, keep in mind, before we were making sure that we are equal or greater, but because we are dealing with a storage that can have much more fluid, we want to make sure that we are equal or less. And honestly, this code is from TurtiWorty, and when I think about it, if we want to test for a recipe, we must make sure that the amount we are sending in is okay. I'm not sure if this is sufficient enough or not, because we are making a check that our amount is smaller than the full capacity of the storage. However, we are not making sure that the amount is proper for the recipe. So I will make another overload for this, and this is mine, by the way. All I'm gonna do is add an integer amount, and here I will say and this dot amount is greater or equal to the amount that we sent in. And that should help me fix any use case that I need for the amount in the future. And now our fluid stack payload is complete. There is one more thing that can sit here as the library for the Jiralib. However, there is one single problem with the implementation we have from 3040, and that is a transfer util. Now, don't worry if you don't understand transferring stuff. Basically, this utility class is responsible of sending something, being it inventory items or the fluid or energy, from one container to another container. However, the way he started implementing it, he says public static t extends transfer variant. Okay, and you see none of that is hard-coded for being a fluid. Even here, he says single variant storage. Now, I don't care if it's called single fluid storage. That's wrong. This is a variable name. It doesn't matter. The thing that bothers me is this, fluid constants.bucket. This means that we are making sure that we transfer an amount equal to a bucket from one container to another container. And this would make sense only and only if we are transferring fluid. For example, if you are transferring energy, the fluid constants.bucket, if you want to take a look at this number, let me copy paste it somewhere and take a look. It's 81,000. So it means that I'm transferring 81,000 units of energy. Or if it's item, I'm transferring 81,000 count of an item. This is not how it should be. I can ask for a parameter here, and that makes sense as an integer or a long actually for the amount, but I'm not sure. This is a transfer API, and it's generic enough to handle both the fluid and the energy and even item, I think, if you use the item transfer API. So that is why I am making the decision to add it under the Jiralib. So I will make a Java class, call it transfer helper, and I don't use the util name. I always use the helper for some reason. It makes more sense for me. Let's talk about it line by line. So I will say public static. We have a generic of v and then a t, that the t extends a transfer variant of v. Now, transfer variant should be recognized, transfer variant should be recognized from the Fabric API transfer for the storage. Now, remember, whenever you have a bucket of water, for example, the bucket contains a fluid variant. The fluid variant is water. And when you want to put it inside a fluid tank, for example, any transferation in the APIs for the Fabric up until now is push-based. It means that the tank is not aware of what is going on. The bucket is responsible of sending the fluid to the tank and make the tank update itself. This is what we call push-based system. In push-based system, one container is responsible of sending the transferable entity or thing or whatever you call it to another container. The container that is receiving has nothing to do with the transfer API. He is not aware of anything. We just transfer the fluid into it and then tell him that, hey, we put something in you, please update yourself and mark yourself dirty. And he says, oh, okay, I will update myself. Oh, I see, I have new fluid or I have new energy or whatever. Now, the process of sending anything from one storage to another storage is handled by transfer API. And if you want to find the transfer API, you can come back to your external resources and find this net fabric API transfer. So net fabric API, and it should be transfer. So it's down here somewhere, transfer. Open it and you see that you have the API version 1, and here it is, the transaction, the storage, the item, the fluid. Now you may say, wait a minute, we don't have energy. Yes, energy is not provided by Fabric itself. That is why you have the energy API dependency. It is provided by Tech Reborn team. We will talk about it later, but if you want to sit back and read and understand everything by code, here is what you will find useful. So you see that we have a transaction. We will talk about transactions in a few minutes. Then we have the storage. Now the storage is something that stores something else. For example, it's a container that stores a fluid variant, or it's a container that stores items, or it's a container that stores energy. That's the storage. Very generic way of handling anything. Now, if you're familiar with Forge, you know that Forge has capabilities. The storage here is really different compared to capabilities. Capabilities are much more complex and, of course, much more powerful, but at the same time, much more confusing. I prefer the way that Fabric is handling things. So we have a storage, and then we have item variant and fluid variant. If I open fluid variant, for example, example, you will see that it just extends a transfer variant of type fluid. Okay, let's take a look at transfer variant. It's an interface actually that has some methods for checking if it's blank or getting the object, getting the components and component maps, and check if it has a component or match the components and compare the types and stuff like that. You can read it. However, when it is being extended as the interface for fluid variant, you see that now we have the codec and the packet codec. For the blank, now we have fluids.empty. Let's take a look at fluids. Okay, we have flowing water, water, flowing lava, lava. Interesting. Each one of them is registering itself with a name and new class, and this is the helper for the registering of the fluid, and it's private. If you want to register your own fluid, we will do it in future. We will copy this, we will paste it inside our register somewhere in the library, and then we will be able to register our fluids. Now in the static log, you will see that it is checking if the fluid inside registry has a next. It will retrieve it, and then it will get the state manager, the state and iterator, and it will iterate through its states, and it will add those states to the state ID on the fluid class. Okay, nothing serious, but what you need to understand is that we already have 4 different fluids, and the flowing water is a different thing compared to water, and the fluid inside Fabric does not handle heat. Now that we understood it, we can continue. So that was the blank one. So it's not water, it's not lava in any shape or form. It's an empty fluid type. And then the of returns the of method call under here with the empty component changes. And here we go with fluid variant implementation of stuff. If you want to dive into this, you can take a look, but all it is checking is that if it's flowable or if it's a steel. And it will handle things like getting the cached fluid variant or calling another implementation, and it will assign the fluid and component maps to itself. These are internal things actually. But anyway, as I was saying, anything that is transferable is inside here. So the process of transferring anything is using transaction. So you can take a look at transaction. It has a nice and informative Java doc, especially on top, but we will talk about it in this method. So let's start with handling this. We send in the type. The type can be fluid or I don't know, item variant, fluid variant, whatever. We want a transfer variant of a type. We return something that is optional of that transfer variant, and we call it find first variant. All we are doing is that we want to check if we have the correct variant or not and retrieve the first one. So we ask for a storage of the same type for the variant. We call it the storage, and then a nullable of the transfer variant again. We call it check first. And then, as I said, we want to have a transfer amount as an integer to dissect it from fluids. Now we want to do some sanity checks. So we say if the storage is instance of a single variant storage, we call it single variant storage, or yeah, that's a good thing. Now, what is a single variant storage? In Fabric, storages are in 2 different kinds. One is the single variant storage. For example, think about a fluid tank. A single variant storage can take only one fluid type. So if you put water in it, you can't add lava on top of it. If you want to put the lava into the tank, you have to empty the tank out of water and then put the lava in it. That's a single variant storage, as the name suggests. But there is another one, I think it was called mixed variant or something like that, and it can handle many different types of the same transfer variant. For example, you can put different fluids inside the tank if it's a mixed variant storage. For example, you can put water, you can put lava, and you can retrieve them based on your own logic. So here we are checking that if our storage is a single variant storage. If that's the case, we can simply return the optional dot of nullable. We want to typecast to the T the single variant storage dot variant. The variant is actually the real thing inside the storage here. It's a fluid variant, for example. So after the variant, you can get the different things from it. For example, if it's blank or I don't know, compare it to another variant, do the components match and the stuff like that. So if it's a water container. So the single variant storage is your water tank. The variant here is fluid variant dot water. That's understandable. Honestly, if we are a single variant storage, that's all we need to do. However, if we are not, then we are face to face with a container that can hold and handle more than one variant type. This time, we need to handle things differently. So if check first does not equals to null, and if not, check first does it blank. So if we have some variant and if it contains something, then we want to try transferring items between the containers, or I should say the variant between the containers. Now here is the thing about transactions inside Fabric. They start as a simulation, meaning that you simulate the transfer of your variant from one container to another. Let's talk about fluids because it's more understandable, especially if I use my handy drawing tool. Now, this is container number 1. It's a fluid tank. This is another fluid tank. And let's say that you have a pipe or a conduit or whatever going from one to another. Now let's say that this one contains water. The moment you finish putting the conduits and it's supposed to transfer the fluid or water, let's say, from one container to the tank number 2, it starts a transaction. And the very first step in the transaction is simulating. So in reality, it will not directly transfer the fluid. Let's say that we ask to transfer a bucket, okay, a full bucket of water. It will try to first extract a water of bucket in the simulation, and it will try to insert that bucket of water into the second container in the simulation. Up until now, the tank number 2 did not get anything. We are just doing a simulation. At the end of the simulation, if everything is okay, if we made sure that the transaction is successful and we want this transaction to happen, this is when we commit the transaction. That commitment is when the actual transaction happens and the water comes into the second tank and will be reduced from the first tank. So in the simulation phase, we actually don't touch these two tanks and we just try to simulate things. Now this is useful because sometimes you just want to make sure that you can transfer something, and as a logic you will return the logic result. And here is exactly one of those examples. We want to make sure that we can transfer the variant from one container to another container, but we don't want that transaction to happen. All we want is to check if it's possible, and if it's possible, we want to return that variant and nothing else. So how do we use the transaction? We start with a try catch phase. We don't have a catch. Normally we start with a try alone, and inside the try we use a transaction and we call it transaction equals to, normally you use transaction dot open outer. Sometimes you use transaction dot open inner. You can read about the outer and inner inside the Fabric wiki pages. They have nice tutorials about this. Then we are in the try block and now we can check the simulation. So we can check if the storage can extract from itself. What we want to extract is the check first variant, okay? And I'm really against the name check first, but whatever. Then we want to see how much should we take out. Okay, transfer amount. If it's a fluid, maybe it's a bucket of fluid, okay? And for this extraction, we are using this transaction. If we can extract it, and by the way, I think the extract, yeah, it needs a long, so this is not solving it. What's the problem? Required type boolean, provided long. This is the resource, that's the correct one. This is the max amount, should be long, so that's correct one now. And then the transaction. Okay, I don't see why you are yelling at me. And oh, we compare if the amount that is extracted is above 0. So in reality, if you would want to do a real transaction, you will see the code later in the next libraries. This is not the correct comparison at that time because we are simulating the extraction. This is the simulation. The storage.extract is a simulation. It will return the amount that was extractable. Keep in mind, the transfer amount is a max amount and the extract returns a long that says a non-negative integer not greater than the max amount, the amount that was extracted in the simulation. If you say that, hey, I want to extract the maximum of one water bucket out of this tank, and the tank has less than half a bucket, for example, okay, what will happen? Here's the thing. We have a tank that has half a bucket. We understood that a bucket in Fabric is 81,000. In other words, right now we have 40500 inside here. Now we are simulating to extract the maximum of a bucket. The result of storage.extract will return this value. So if we really want to transfer a bucket, this is not the correct check. We would want to check if we were extracting the correct transfer amount. Okay, is greater or equal. This would be the correct code. However, here we are not doing a real transfer. We just want to see if we can do the transfer, if we can extract the type or variant that we want. And as I said, I'm totally against this name. I don't know why did Turtle use this name. It's so confusing. Let's call it variant. That makes much more sense. So we want to see if we can extract this variant from the storage. Basically, we want to see if the storage has any amount of this variant. If that's the case, we are not committing the transaction at all. What we want to do is finish the simulation and return an optional of the variant. So we found our variant. Okay, we just return it. Otherwise, if we didn't find the variant and the variant is there and it's not blank, but we didn't find the variant inside the storage, then we want to return the optional.empty. We didn't find anything. However, we are not done yet. We may send null as the variant, or the variant is blank. At this time, what we want to get is the very first type that is in the storage. Okay, so we say for storage view. Now this name is really confusing for the beginners. We call it the storage view inside the storage.non-empty views. Then at the very first loop, we are checking if the optional.of-nullable of a storage view dot get resource. And why of nullable is not working? Because this is optional, not option. Okay. At this stage, we checked if we have anything in the container that is nullable. If we didn't find anything here, chances are that we had done something wrong in our code, but okay, whatever. At the end, just return the empty. Now, what is this storage view? This is really confusing at the start for beginners because it says a view of a single stored resource in a storage for use with the iterator or whatever. But hey, a VU, well, for someone like me that had programmed something like Unity 3D and at the same time had programmed something like C# Windows applications, a VU means a user interface. However, here we are not talking about user interface at all. Think about a street with different shops, and each shop has a window, and in each window they represent a single thing. Okay, when you are walking in this street watching these windows, what do you see? Each window is representing one single thing, isn't it? That is your view in a storage. So a storage is the street itself, the views are the shops, and each shop is representing one thing. That thing is the resource here. Okay, I think that makes things a little bit clear and helps you figure out and imagine how this internal system is working. So here we are asking, hey, please, storage, give us everything that you stored. So the very first thing that we stored, we check if it's nullable, but we want the type. So hey, the shop, please tell me, what do you have in your window? If it's nullable, I just want that and get out of this method at all. Okay, so that's the whole thing. The normal way of using it would be to send in a storage, for example, a fluid tank, then the type, we want the fluid type of water, for example, and a full bucket. So we want to see if the fluid tank contains a full bucket of water. If the tank only holds one type, that's that. If it's not, then we want to see if we can extract one bucket of water from the storage at all, because we provided a bucket of water here. It's not null, it's not blank. But if we send null, means that, hey, we don't care what is there. Please give us the very first thing that you have. And it will try to give you the very first thing you have. And at the end, if something is wrong, maybe the storage is not defined properly, or for any reason this logic is failing and not throwing any exception, you will come here and return the optional.empty. And that's about the whole transfer helper here. This is a very powerful code, and I think I had close code for the fluid transfer. Let me see if I have it. Actually, my code is just transferring things. It's not just retrieving anything from a tank or any storage. So I have a simulation code, but yeah, I'm not retrieving anything from the tank. This is a powerful, actually, code that can be used in many different systems, being item transfer, conduits, for example, or pipes, being the energy transfer, being the fluid transfer. This code can be used everywhere. Now, at the end, I have to go back and delete the Maven artifact inside repc. So we are inside Jiralib, and we want this version to be deleted. This is we delete this version, as simple as that. I already had emptied my cache, so now we need to re-upload the publishing to Maven, and I will come back when it's finished. And the last step is for our Ultra IO to be resynced again. I will come back when it's finished. As you see, it re-downloaded the Mavens, and again, our errors are gone. However, now it's not yelling to us to implement the missing method of the tick client end or something like that. And what is, water generating, and this is water eating. Okay, just double check that we don't have any errors anywhere. We shouldn't. Okay, the only remaining problem in our main right now is related to machines, but we can't come back to machines anytime soon because we have to cover many different things inside our libraries. Now, keep in mind, from now on, I have to work with the transfer API because I want to handle the fluids, the energy, and inventory. This is about the storage. Then we go back to fluid and energy. I will handle inventory first. And at the end, we will have the gmachina. And in gmachina, we will produce some abstraction layers on top of what we have inside fluid, energy, and inventory. And we will have our abstract machine block or abstract activatable machine block. And finally, that is when we can get rid of these errors. So in the next video, we will start talking about the inventory system inside Minecraft.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.